Okay, good morning. Welcome to
FamilyMath 751.
FamilyMath 751. Sorry, we have a power cord issue. Alright, so today we're going to talk about sums of divisors. And the reason we're talking about this is you learned about this in your idea math class yesterday.
Yep.
What does it mean?
So it's like the divisors of a number are where you can like take one divisor and then multiply it by a specific other divisor, and then you'll get the number.
Alright, well, let's use 10 as an example. What are the divisors of 10?
So you have 1, 2, 5, and 10.
1, 2, 5, and 10. Okay. And we can actually ask, what are some questions we can ask about the divisors of a number?
Well, how could we, if the number is, if you have a lot of divisors, how could you write the sum of the divisors?
Okay, so we could talk about the sum.
Like how to find the number of divisors.
The number of divisors.
I guess like how the number of divisors sort of tells you about how big the number is.
What tells you how big the number is?
Like if a number has a lot of divisors, could we say that most of the time it's going to be a large number?
Oh, okay. Yeah, it's hard to know what you mean generally by a large number, but yeah, you can ask some questions about what do the divisors mean about the number. Any other questions we could ask about the divisors of a number?
Well, you had to how to write the sum, or different ways to find the sum.
Yeah, well, that's what we're going to talk about today. And another question might be, for example, the product of the divisors, which for 10 is what?
It would be 100.
Yeah. Do you think the product's always going to be a perfect square?
No, but it'll be. It's when you write the divisors like this, each pair of divisors is going to sum to your number.
Uh-huh.
So unless you're
say that one more time.
Each pair of divisors is going to multiply to your number.
Okay.
And unless your number is a perfect square, your sum or your product of products is going to be your number to some power.
Okay.
Unless it's a square, in which case you have to multiply by the square root of your number at the end.
Okay, so give me an example of a number that's not a perfect square, where the product of the divisors is not a square.
So if it's not a square, so what about something like you could try 18 or
Okay.
oh, I'm not entirely sure.
Alright, let's see. What are the divisors of 18?
So you have 1, 2, 3, 6, 9, and 18.
Alright, what do we get here? Do we get a square when we multiply them all together? Because I get 18 times 18 times 18.
Well,
Is
that's
that a perfect
18
square?
cubed, but it's not a perfect square.
Not a perfect square. Okay, what's a different number whose product of divisors is not a perfect square?
Well, I think 20.
Okay. So 1 and 20.
2 and 10 and 4 and 5.
Alright, so there it looks like, again, we get a cube.
But any number with, I guess, that isn't a square and has an odd number of rows when you write it like this,
Okay.
it's going to work and not be a square.
Alright. Can you think of any other ones?
Primes.
Ah, that's what I was thinking of. Primes. For example, 2.
No.
It's going to get 1 and 2. 3.
Because
You're going to get 1 and 3. 5. 1 and 5. So, the product is interesting, but today we're going to focus mainly on sums.
okay.